we're going to calculate the total surface area of a cone in this video. So a common example of where you can find cones in everyday life are in your freezer or in the freezer of a supermarket in the form of ice cream. So ice cream cones are obviously in the shape of a cone, hence the name ice cream cone. And if you're having problems looking at this cone and recognizing it as that shape, I want you to think of a drumstick. So the ice cream drumstick, I want you to imagine someone's got it and they've tipped it upside down like this on your piece of paper. This is an upside down drumstick cone, okay? The first thing that we're going to do, like we have done for every single other example, is write down the total surface area formula for this shape. So the total surface area of a cone is pi r squared plus pi rs. Now I'll show you where both parts of this formula come from. The first, which is the pi r squared bit, comes from calculating the area of this circle down the bottom here that I'll just shade in green. So you should know that the area of a circle is pi r squared. The area of a 2D circle is where this first part of the formula comes from. It is literally calculating the area of this bottom circle here. So this is the area of this circle here in the shape. The second part of the formula, which is the pi rs part, that is the area of the remaining leftover of this curved part of the cone. So imagine you're holding your drumstick cone right now. That part of the cone that you're holding onto, that whole entire curved surface, the pi rs is the formula for the area of just that curved cone part. So I'll write this is the area of the curved surface of the cone. Okay, so add them both together, the area of the cone and the area of the circle down the bottom, and you get the overall total surface area of the entire shape. So you'll notice that on the formula sheet on DayMap, there is actually a factorized version of this formula, and I'll show you how to get that. So I'm going to factorize this part of my formula. So my total surface area equals, now when I say both sides of the equation, I actually mean on either side of this plus sign. So this side and that side. Over here, we've got pi, and on this side of the plus sign, we also have a pi. So we are allowed to take that pi out. So you're only allowed to take out if something from one side is also there on the other side as well. If something from one side doesn't appear on the other, then you're not allowed to take it out. So this is just factorizing. Now over here, we've got two r's, and on this side of the plus sign, we've got 1. So this is, the plus sign is our middle, okay? On this side, we've got 2 r's, and on this side, we've got 1. So we can take one of those r's out. Obviously, we can't take that other one because there isn't another r on this side of the plus sign for us to take. And this s that's here on the end, well, there are no s's on this side of the plus sign, so we're not allowed to take that either. That means we can do an open bracket, and on the inside of the brackets, we take the leftovers. So there was 1 r left over here, then plus, then an s that's left over here. And that's how we get the factorized version of this formula. Now, when we see S's anywhere, the S just means the slant height. So S stands for slant. R you should know because R is radius, and we've done that with 2D circles. So now that we know that our radius is 3.5 millimeters and our slant height is 10.1 millimeters, we can take these values and substitute it into our formula. TSA equals, now the pi, no gaps equals imaginary time sign, so times the radius, which is 3.5, bracket the radius again, plus our slant, and the slant is 10.1. Closed bracket. Now what you see here is going exactly into your calculator, exactly how you see it, like I always say. So I've got my calculator here, and I'm going to put pi, as in the actual pi sign, times 3.5, open bracket, 3.5 again, plus 10.1, closed bracket, equals, and we're going to round to 2 decimal places. So we get 149.54. Our units are in millimeters, and we're dealing with area. So our answer is squared.